Good morning, everybody. Let's start some coding. Let me know if my sound is in sync with the visuals, because we had some problems last time. And let's start doing some animations. Yeah, glad to see you guys again too. Let's start doing some. I just need your feedback on the quality of the sound and the visuals, all the stuff, and we can start. Come on, give me some information. It's okay. Yay! Humans 1, technology 0. We won. Alrighty. So I'm gonna try to implement something new. It's actually from a Russian website. I don't know, maybe they took it somewhere. Anyway, I like this animation. I'll switch the screen now so you can see it too. Yeah, so it looks like this. It's like a bunch of dots with the trails. It's like really lots of those dots, and they also react to the mouse movement. And they have those trails, and they leave those trails like forever. So it's not. And that was what's been bothering me. Like, how do they leave the trails, and how do they pop new particles, and how do they react to the mouse movement? And like, it was something weird to me. It's the animation I've never done before. And I decided I should dig into this one. I should maybe open the chat too, so I can see it. Yep. This is weird. Yeah. Yeah, so let's implement this animation with the dots and with all this stuff. I'm going to be using Three.js for this one and the parcel. So I'm start with a basic kind of template. I'll call it trails. Have my basic Three.js template in place, which is just the HTML and the JavaScript file. And HTML is quite empty, I should say. So it's just the JavaScript link. Okay, I'll make it bigger. Just some, removing margins, paddings, and then that's it. Not much to see here. And then the JavaScript is my usual basic Three.js template. Resolution is not okay. Like, what do you mean resolution is not okay? What exactly is not okay? Seems to be like the always, like the default one. All right, let me know. The screen is not readable. What the hell? It's like new issues all the time. And why is it not readable? Should be okay. Okay, I got you. Screen has artifacts. Well, let me check that. Yeah, but like, why this is happening? Oh my god, I didn't change a single thing there. Why would that happen? Like, honestly, guys, I have no idea what is happening. Maybe YouTube changed some settings or whatever. I'm gonna try to restart the video part, like, probably. Then activate it again. Is it good now? Honestly, guys, I have no idea. All good now. And you know what I did? I just hit deactivate and activate. Gosh. No freaking idea. Yeah, okay. I'll show you the code now. I'll just open it in Sublime. I had to restart the sound last time now. The visuals. What is the reason? So that was the HTML. And well, yeah, that's it. Not much to see here. And I have the basic JavaScript, which just has two shaders and the Three.js library in place, and you know, some basic scene setup for the Three.js scene. It's not much, it's just one object, and I don't really need a lot of stuff I'm using here. So it's actually 100 lines of code, somewhat like this. I already showed this template in the previous streams, and probably if I just run this template in Parcel, just like that. Well, hello to Ghana too. Thank you. I wouldn't expect someone watching me from Ghana. All right, so I have some dependencies downloading from the NPM, and we're gonna see some Square pretty soon, some 3D Square. All right, yeah, here we go. It's just UVs on a plane. If you try to build something with the shaders and a Three.js, you probably know how it looks like. So I have those two shaders in place and just coloring it the UV, and I can do like this, the red one, whatever. It's not available, but you can build it from any Three.js basic example, whatever the way you like. There's nothing special in here. So the only thing kind of special is that I'm building shaded material here, which had a lot of examples on the Three.js website. Anyway, we need to build those dots. We need to animate them somehow. So first, I think it's done with the point, with point kind of object. So I need to build the point. I'll leave my shader material right here. I also have this basic, I'll need a bunch of stuff. Basic shader for the, like this is the whole code. Basic shader for the particles, distributed particles. The only difference from the basic, you know, any other vertex shader is that we have the point size variable here. We need to set the size of the points. So let's build some points on the screen. So instead of building this plane, I'll call it these dots, and then I don't need plain geometry anymore. I think I'm gonna go with the buffer geometry. Yeah, and then buffer geometry is just the empty kind of placeholder object. So to make it with something, I need to fill it with some data. I'll pick the number of particles, let it be 100. Then I'm going to create the positions array, because obviously I need positions for each of my particles. And then it's going to be new num multiplied by 3, because each particle has 3 numbers corresponding to this. And then I'm going to do the loop, and inside of that loop I'm going to be just setting my position. This float 32 array has a method called set, and inside of this method I'm going to just set 3 random values. And I have to point directly in which place to put them inside this array. So there we go. And then I need to connect somehow these positions to the buffer geometry. This is usually done with this geometry set attribute, and then I need to set this attribute, like the name of the attribute, and I need to create new buffer attribute out of those positions, and that would be just the positions, and I have to set the number of values that correspond to each of the vertices in my geometry. So I guess that's it. Yeah, we set those things. Should be good now. And then instead of creating the mesh, I'm going to be creating points. And probably, hopefully, we should see the points now on my screen. We don't see them because it's position is not defined, because positions. Okay, we have positions, we still don't see anything because of, okay, we have them, but they're just too damn small for some reason. So maybe a bit bigger. Why are they so damn small? I have this camera. Where's my camera? Is it maybe so far? No, camera is not that far. Okay, I'm not using my shader for the particles yet. That's why I'm using the default shader, and the default point size, I think it's just 1, and it means it's just 1 pixel on the screen, which is hard to see. If it's just 1 red pixel on the screen, yeah, it's kind of hard to see. What I need to do, I needed to switch to this particles shader, which has just 1 line difference from the original one. But anyway, now I have the particles in place. So now it's 3D particles somewhere on my screen. We have them. All right. Now the next thing I want to do, I want to kind of try to move them first. I want to see some movement of my particles on the screen. First, I'd like to make them a bit more dense, so they are closer to each other on the screen. What have I done? There's a typo somewhere, but I'm just I can just, oh, okay, I forgot to close and bracket. Right, I'll break it down like this, so it's at least a bit easier to see what's going on here. Yeah. Okay, yeah, now they are pretty dense, and now I kind of want them to move in all the imaginable directions from this place, but in just one plane, just an XY plane. Let's try to do that. For that to happen, I think I need another variable like the angle. And angle is gonna be just an angle, it's gonna be just single angle for each particle. And then this angle I'm gonna be setting again in this same loop, but instead of 3 values, I'm gonna be setting just 1 value. And kind of wanted this value to be in the range between 0 and 6.2. Like this. Yeah, it's all good. Because this is an angle and this is the whole 360 angle. Now I need to set this attribute here. Attribute, which is going to be a float and angle. Now I want to move my particles with my angle to all the directions. To move something in the direction of an angle, I think I will be forced to take the sine and cosine functions. And I also need to come up with some new variable, which is position. And so this new pos is actually something small. It's something in a range from 0 and 0.1. So I kind of small, you see the all centered on my screen. And now I will be adding some value to this new pos, and I'm going to be showing this pos on my screen. And to add some value, I have the time running the whole time. So it's some number which is going from 0 to infinity. Okay, and then I think I'll just plus x. We'll be just adding. So this is a static position, starting position, and then I will take the cosine from the angle and multiply it by time, and then I'll do the same for the y value, but instead I'm going to be taking sine. Let's see what's going to happen. Well, maybe the Time is running too fast on this one. Something like this. Or do I have some error in the shader? 67 line. Oh yeah, it's not 4-dimensional, it's 3-dimensional vector. Right. So now they're moving in the same direction for whatever reason. While they should be moving in different directions. Okay, this value is good. Just need to check everything. Well, yeah, it's good. The angle is good. Okay, I'm not connecting the angle actually. Yeah, I'm not setting the attribute. That's why. And it considers it just a 0, and because it's 0, they all go in the same direction because 0 is the same angle for all the particles. So yeah, angle should be good now. Still going in the same direction. Why would that happen now? Shouldn't be the case anymore. Any ideas, guys? Why would the angle be the same now? Set the attribute. It's an angle. It's 1. The values are good, probably. I'm gonna just output. You never know where you make the mistake, you know. And the usual is so dumb, so simple. You're just missing some simple stuff. So I'm just gonna see the angle, and all the angles are still 0, so I probably have an error right here because I'm still setting positions. Fuck. Not the angle, I just copy pasted the code and forgot to change them positions. Yeah, so now they're going in all imaginable directions. The speed is a bit different because the starting position is a bit different. So speed is not really different, it's just the offset is a bit different. But it doesn't look fun yet. Okay, let's make them rounded while we are here. I need to calculate some distance from the center. It's usually like the length, and I think something like gel point chord. Yeah, it's like this. Thank you, Google Chrome. This is a coordinate system inside of each particle, and then I can subtract the center of the particle, which is 0.5. This is actually 2 0.5s here. I'm just using the shorthand for this one. And well, now I can actually see this distance. I'll call it d. So instead of particles being a square, I'll make them a bit bigger so we can see. I made a mistake. I think it's 1, 2, 3 values. This comma shouldn't be here. Still have some syntax error. Point chord undeclared identifier. So maybe it wasn't right. Maybe the capital P. Yeah. Yeah, it's all good now. Now you can see the distance inside of each particle. So I'm calculating in a fragment shader the distance from the center of each particle. And knowing this distance with a smooth step function, we can actually build something like a particle border. I'll be calculating some transparency, and this is going to be smooth step. And because the radius should be 0.5, because we are already in the center of the particles, so the radius of this circle should be 0.5 at maximum. And this means that 0.5 and then this value d. And then I'll make it red, but transparency is going to be set with this value alpha. And I need to set them transparent true, obviously. Yeah, now we have it like a circle, but we still need to invert that value. So now they are in particles. And another thing I would like to change, depth test false, depth right false. Yeah, just to get rid of all those weird edges and all the stuff. So now we have the particles. It's kind of we're kind of approaching this thing already, right? But just not yet there. So we're still missing one huge detail. First, the particles are not being looped, so I have to refresh manually each time just to see the starting animation. For that to happen, we need to loop the animation. To loop the animation, we need to set something, so each particle has to have has to return to the starting position at some point. And for this, we will introduce the life parameter. Yeah, we just need to put some life into this. Life is going to be the same kind of thing as the angle. I'll do this, and life, well, I already know which values I need kind of to arrive at my destination. So it's going to be like something like 4 plus math random multiplied by 10, for example. So those values are from 4 to 14, right? They could be any. It's just the matter of the numbers. The particles might move faster, slower. Just depends on the loop, on your timing parameters. It's not really that important for now. I also want to set some random offset for each particle, so they will have a different life expectancy, and they also have a different offset. Might call that one an offset, and it's going to be something big. So I want them to be real different. Offset, and then I need to introduce those values here, offset and also life. I will need to add them here too, offset. So I'm just adding some data into my particles. Yeah, so just wait a second, we're going to be using some more math here. What I was going to do, when I read the chat, I immediately get out of my context. So I just added life and offset things, and now I kind of need to loop each particles inside these life and offset values. So to loop something, the simplest thing to do is to use something like, we'll use the current value and use the modulo. And I'll be taking the modulo from offset plus time modulo life. So this will just run the whole time will run from 0 to life, 0 to life, 0 to life. And life is between 4 and 14, as we remember. So then I could calculate the percentage, like the life in terms of from 0 to 1. So the percent of life is going to be current divided by life. This might be different for each particle. You can remember that, right? So the life expectancy could differ like 3 times between them. And then we have this percentage for each of the particles. All right. Now we have it. Now I can use this percentage instead of using this time value. I can just use here the, I don't know, maybe the current, because we can just multiply this by current. Let's see what's going to happen. Do I have some error here? Oh yeah, I forgot to declare all the new attributes, life, offset. Yeah, so now particles are moving and they are looped, because when they die, they just immediately arrive at the starting destination. I wish it was like that for the humans too, right? Okay, now we have this loop, and because it's particles, you can actually have I'll make them smaller. It's too small, maybe like this. And then now you can see that the life expectancy just changes the speed of them arriving at the same spot and all this stuff. Okay, and what I wanted to change to, kind of wanting to change the radius, like how far they are going now, maybe so they go a bit further, maybe like that. So they still disappear while they are on the screen. And then what I wanted to show you, that we can actually have like 10,000 of those, and it kind of looks good already, right? It's just some particles, volcano, I don't know. Let's look at this for the moment. Now, what I don't like about this is the particles disappearing the whole time, like when the life is on the end, they just disappear. I want them to fade away. I think it's gonna look much better this way. I'll stick with 1,000 for meantime, and then I kind of wanna calculate some alpha transparency for the particle, which is gonna be dependent from their life. So when they're dying, they're gonna be fading away. Oh yeah. Oh yeah. And I'm gonna call this V alpha. I'm gonna be using this here. I'll just multiply this with V alpha. Okay, so far so good. Now they're all transparent because V alpha is 0. I'm not setting it anywhere. So now I'm gonna set V alpha as a smooth step again, the best function. And by the way, there's a recent video at the Art of Code YouTube channel about the smooth step function, and I really advise you to see this one. And so when they start their life, I kind of want them to also fade in. It's not just popping up in the center of the screen, but fading slowly. So I'm going to use this percent value, and when the percent value is just from 0 to 0.5, it's going to be fading. It's not going to be going fast, it's going to be fading. So, and then after the life is, okay, after the life is bigger than this value, like the life, a teenager particle already, it's going to be just fully, you know, with the transparency 1. So now you kind of see this, they're fading really fast in the center of the screen. And I want to do the same to the end life of the particle. And for that, I could just subtract the same smooth step function, but in the end of the life of the particle. So I'm going to use 185 and then 1%. So this curve is going to be going the other way. And it's actually, I don't know, I kind of want to draw you the curve so you understand what is happening here. And the easiest way is to Photoshop, I think. So don't need brush, I need pencil. Why is it so big? So I have this coordinate system, and then this is what's happening with the transparency. It's just 1, it's 0, and this is what's happening with the transparency of the particle when they grow old. That's what I'm doing here, but this is actually smooth, like this, and then going smooth back to 0. Well, they're still disappearing because I didn't save the shader. And now you see them fading away. They're not just disappearing, but they're just slowly fading away when they die. It looks much better now already. We have this particle system in place. I don't know what else. I think we're kind of ready to implement the main animation. And for that to happen, you can actually notice that we're kind of preserving the previous renders. It's not like we are clearing the render and then just drawing something again. It's like we're drawing on top of previous frame the whole time. And for that to happen, we just need to preserve drawing buffer. This is what it's called, like. So I need to set my WebGL renderer to preserve current buffer, which is here. I'm gonna set it to true, and then also set it to alpha to true. I don't remember if I need that really, but just in case. Nothing really happened so far because the WebGL renderer has the auto clear parameter, which is set to true by default. And if I set the auto clear false, no, it's not like that. WebGL renderer auto clear true. Oh, it's with a capital C. Still not there. I wonder what I messed up this time. So I think it's preserved drawing buffer true, then the alpha is also true, and then the auto clear is false. Not clearing it anywhere here. I got some small detail. Maybe set it like this. Yeah, it's not like the options parameter is just the parameter of the renderer. And now what you see is that we're preserving each previously rendered particle, so we just have this. It'll look kind of fun, right? So each particle is going in the same direction, but it's all reddish. It's just you can't see anything. Just kind of beautiful in itself, but it's not what we are heading to. To change that, we actually need to add some color, some clearing color, because right now it's just red and transparent, just red and transparent the whole time on top of each other. We need to add some other color, and I will just add the plane here in my add objects function method. I'm gonna be I'll call it this clear plane equals new create new geometry, plane geometry, big one, so it fills the whole screen. And then I need to set some material for this one. It's gonna be just mesh basic material, transparent true, blue, and well, then I can send the opacity something small, and I'm ready to add it to the scene. This scene at this clear plane. Let's see. Yeah, it's starting to look somewhat cool. I think to make it look a bit closer. Now you can see the difference, like on the edges of the screen, I still have, they're not filled with the blue with the blue plane, and you can see the difference where I'm not putting another color on top of the others. Already kind of cool, but I think I need to get even smaller than that, something like this. Yeah, it's getting closer, right? Somewhat. Of course, they're starting the particles from the bottom of the screen, but that doesn't really matter. I can change. All right, I'll make the plane bigger, just a bit bigger, so it fills the whole screen. Now it kind of looks cool, but what we are still, by the way, if I just try to move my orbit controls right now, the weird stuff's gonna happen because it keeps on rendering the whole stuff again and again, and it's just some digital art, I guess. Some randomness on your screen. But if you put a couple of those planes with a different opacity, I think you can come up with a pretty weird cool results here. Now I just have one plane, and just so you remember what's actually happening on my screen, I remove AutoClear false for a moment. It's just particles, and then the semi-transparent blue plane, which you couldn't even see because it's so transparent. It's just 1/100th of the original opacity. Yeah, if I just remove AutoClear, it's cool again. So one of the final things I wanted to do here also the mouse movement, because on this website, when you move the mouse, the particles are actually moving all those weird directions, and I kind of like it. For that to happen, I need Raycaster. Let's take it to our template. Okay, I have the variables in place, and then oh my god, it somehow started too hard to select the text with the touchpad on the recent update or something. Yeah, I need to add this event listener call. I'll call it mouse. This mouse, not this mouse move, because I already have this mouse, and I'll add it somewhere here. This mouse. What am I doing? Do I even know JavaScript? I don't think so. All right, self this. Now I started using self because if I use self, it's being highlighted in a subline, because if I use that, it's just boring that, but self is such a self. So I'm gonna be using self. I'm gonna be setting the mouse position here on the mouse move, and then on each mouse move I want to raycast and see where my ray hitting the plane. So I'm gonna put all those into the context self. Then I'll be having the intersect variable, which is this Raycaster. Yeah, maybe, but you know, it looks beautiful. You can see it on my screen. This is the only reason I'm using self right now. It kind of looks better on the screen. And instead of this scene children, I'm gonna use the plane I already have in place, this clear plane. And then this is an array, and if I check for the real intersection between the array and that, I just need to check for the existence of the first element in the array. If I have it, I'm gonna set the point. If I remember it correctly, it's gonna be, if I remember that right, it's gonna be point. And let's just cancel log this for a moment. So I've done a lot of things, and I need to see intersect objects of undefined. Self. All good now. Yeah, now I have the 3D position, and now I can set the uniform. I need to create the uniform first. So it's going to be U mouse position, 2-dimensional vector. Let it be 0, 0 for a moment. And then I need to set this U mouse here. It's going to be self, material, uniforms, U mouse, value equals. Yeah, it's going to be px, py, because this is a 3-dimensional vector, and I need just the 2 dimensions because my particles are in the single plane, not real 3D. Okay, now I have it. what I need to do now, I need to use it somehow here. It's going to be uMouse. Now I need to calculate the distance. Why do I use fidgets? Because I just got used to it and I like it. I try to, you know, to be open to new frameworks, and I tried the OGL and I do some animations with Pixie. It's just that I didn't have a chance so far to use Babylon. I think it was kind of more game-centered. I don't know, actually. It's just my thoughts about Babylon. I haven't really tried it yet. All right, now we have this uMouse. Now I have to calculate the distance from the uMouse to the current position. So we have this new position. I'm gonna what should I do? Maybe I should copy it to some new, like pos equals new pos. So far we calculated the position of the particle on the screen, and now I kind of want to distort this position with my mouse. Yeah. To do that, first I will calculate the distance from my mouse to the current position of the particle, right? Yeah, right. I just remembered one new cool idea. No wine today. I'm sorry. Not in the mood for wine. Yeah, I'm a bit stuck for a moment. Just let me. Babylon's huge. I don't know. I need to Google its size. I don't even know its size. Yeah, let's just calculate the distance, which is gonna be the distance between two two-dimensional vectors. One is pos xy, and another one is the actual uMouse object. This is the distance. Now I should have some kind of mouse radius, float radius, mouse radius, which is the space where the mouse could affect the particles. Well, because my screen is like 3 or something, I think 0.3 should be good. It's quite a small value, but it's not too small. So now I can just divide this distance by the mouse radius and calculate some kind of strength. So float strength, it's gonna be equal dist divided by mouse radius. So this value would be actually growing from 0 to infinity, because like the more the distance, the more is going to be the strength. So I can invert it the same way I did it with the smooth step here, just subtracting from 1. I can invert it the same way here. So I'm just gonna overwrite this same bar with the 1 minus smooth step, and then I need to take into the account the radius probably. But the radius is already taken into account because I divided it here. So I just can do it like this, from 0 to 1. So when the strength grows from 0 to 1, meaning the distance grows from 0 to the mouse radius. And this value should be the strength, which is maximum at the mouse pointer, and then gets less and less when the distance grows. Yeah, it's the same way that we calculated this shit, actually. It's completely the same thing. Yeah, okay, now we have this strength. Now I need to use it somehow. Now, there are a bunch of ways you can distract the particles. Okay, I think I moved the plane, yeah. But the guys, for this particular animation, they used quite an interesting way. I'm gonna show you which is this way. So when the strength of the mouse power grows, they actually try to move the particle with a circle. And to do that, they calculate first the angle from the mouse pointer to the particle. Let's do that. Tx gonna be equal minus like that, and then I could calculate the angle, and the angle is going to be angle I'll call it, because I already have the angle parameter here. It's going to be A10. So now we have this angle, and this angle actually changes when the particle travels through the mouse field, right? Because the mouse stays in place, the particle travels, so the angle changes. And now we could use this angle to draw some curve. So I'll be just adding something, the new pos x. I'm gonna be adding the cosine from this angle, multiplied by strength. That's it. And the same I'm gonna do for the y coordinate, but with the sine. Let's see what it brings us, because we wrote lots of code and we already have some errors. Undeclared identifier. Yeah, now you can see that when the mouse is close to the particles, they start to travel. I think it's too far. I need to multiply this by some small value. Maybe also the radius is too big. No, it wasn't too big actually. It's rather too small. Yeah, now you can see that when the mouse approaches some particles, they start to move in, like the movement is distorted now. It's pretty cool. Okay, the next and maybe the last thing I would like to do. So maybe seems too big to me. Yeah, this way I would see the end of the life of each particle. Now I could distort them. Maybe this is too small now. Yeah, you can play with the numbers here, but you can see that I can change the trail of each particle if it's getting closer. Okay, maybe I should make them run slower. For that, I would just divide the time here. So you kind of can combine the slow movement of the particles with the fast movement within the mouse range. Alrighty, I think this should be good. And then the last thing I want to do, you can actually change the direction, because I think I had this angle thing, yeah? I want to change it to dir, which is equal to angle. Nothing's going to be changed so far, but I cannot change this angle depending on the time value. So I can take the sine from time, maybe divided by 10, and let's see what's going to happen. It's becoming even cooler than that. They're moving spiral one direction, then they move in spiral the other direction. That's pretty cool, yeah. I think we can just make this deviation a bit smaller. And this is it. I think we are pretty close to the original animation. Now we can just make those particles a lot more. Because I have just 1000, I think I can have pretty much 20,000. It's still gonna be looking cool. Maybe I could also space them out a bit so they don't start real close to each other. And to change that, I have to change where is that? Where's my buffer geometry? Yeah, those math randoms, maybe I should, like, they're still at the center but a bit separated. Doesn't really help. Maybe just 20,000 is a bit too much. All right. Yeah, looks better this way. So there we go. I think we did a good job at replicating that animation. It looks pretty cool. It also uses this new technique which I never used before, this preserver and buffer, and then drawing the whole time over and over again. And you can get pretty neat effect with that. Of course, it's you have your constraints, because it's kind of hard to draw something in the exact spot which stays constant. But it's possible maybe combining a couple of render targets and making the code a bit more complicated. But so far I'm kind of glad with this effect, glad that I learned it, and I hope you understood how to make it. Yeah, you can actually make this same effect with the Canvas 2D, but you won't be able to use this amount of particles there. Because in Canvas 2D you can also use the clear rect function, and then clear fill function, with which you can fill with the semi-transparent color the whole time. Yeah, but with this it's a bit more, there's a bit more power to you, a bit more performance, so you can use a lot more. Oof. If you have any questions, go ahead. I think I would like to dedicate this stream to my parents because I really love them. They are the best, and if you love your parents, please contact them. I think in times like this, it's what we need to do, is to stay in contact with the close ones and to tell them that you love them, if you love them, of course. I hope so. More often. Yeah. How can you contact me? I have a Facebook, I don't know, Twitter. You can write me on Twitter, on Facebook. You can also support me on the Patreon. Not directly you, but I mean, like, anyone who wants, you can support me on the Patreon. And this was the original website, if anybody interested. There we go. It's not that of a complicated animation, but it looks fun. And it's looped, so it's forever. Hope that you like that. In a good morning. Hope your day will be good. I'll stay in the chat maybe for a minute or two. You can contact me on Twitter or anywhere if you have any questions. And I wish you a good day, and tell somebody something good today. Do something good.